Okay, in this video we'll have a look at how we can find the area of a triangle and using different information here. Let me show you. First things first, we'll draw a triangle, and it can be any triangle. It doesn't have to be a right angle. It can be just a regular triangle. It can be equilateral. It can be anything you like. And to do this in a general way, to get a formula, what we'll do is we will label the sides and the vertices. So we'll call it A, B and C. So here's a triangle called ABC, and what we do when we're labeling sides, we often use capitals for the vertices, the corners, and lowercase, and we use the same letter for the side that's opposite. So here's vertex or corner B, move across, side B. Similarly C, and then side C there. Okay. Alright, so that's how we're beginning. And let's pretend that we have information about this angle here. And that angle we will call theta. Okay. So, what can we say? Right. Well, if we were to do the area of a triangle, area of triangle ABC is half base, which is BC, times the perpendicular height. Okay, half base times height. Okay, well, we know the length of the base is BC equals A, so we've got 1/2 A, and then we'll call the height H. And where is that height? Well, I'm just marking it on the diagram now. We'd have to do a perpendicular line with H there. Well, let's pretend we don't know anything about that, but we do know this, that we now have a triangle which is right angled, okay, with an angle theta in it. So what we can say then is that sine of theta equals the opposite, H, over the hypotenuse, which is B. Okay, so here's my angle, there's the opposite, and there's the hypotenuse of the right angle triangle. Okay, so from here, if we multiply both sides by B, then they will cancel out. So I'd have to do B times that. So the height, H, is B sine theta. So putting that together and substituting it in, we now have the area of the triangle is 1/2 A H, but H is B sine theta. Okay. Alright. Now, as you can see from that, A and B and the angle, what we've got is, it's the title now. If you look at the title, finding the area of a triangle, given two sides and the angle between them. Okay? Alright. Now, what happens then if I was to do the same diagram-ish? Label all the sides, and let's say that I'll call this one alpha, just for the heck of it. Here's a different one. What would the area be on this one? Well, it's 1/2 A is the base, and then the height would come from C and alpha. 1/2 AC sine alpha. Those two are identical, and I'm not trying to confuse you there. All I'm trying to say is if we label them different ways, it won't really matter. So if I just do a triangle, any old triangle, I give you the angle here as X. I call this side, this point F, this is P, and this is M, just for the heck of it. Then this is side little m, this would be little p, and this would be f. So if I know the angle x, I know this angle is x degrees, then the area will be half. Now, the title again, finding the area of a triangle. It's got the angle between the two sides. Half p f sine x. That's it.